we're going to start our problem with a rectangle. Then, on the left part of the rectangle, we will put one circle. As you can see, this circle will be intersected by the rectangle. Now, let's say that the segment from the left side of our rectangle to the bottom intersection point with the circle has the length of 8, and the top segment from the left side of the rectangle to the top intersection with the circle has the length of 11. Now let's put another circle on the right part of our rectangle, and as you can see, it is also intersecting our rectangle. Again, let's say that the length of the segment from the right side of our rectangle to the bottom intersection point with this circle equals 6, and the segment on the top between the right side of the rectangle and the upper intersection with the circle equals 4. Finally, let's say that the middle segment, which represents the length between the intersection of two circles on the bottom, equals 12. The question is, can we somehow calculate the upper mid intersection in between those two circles? Now, this question was presented to me by one of my subscribers, Amir, and he also sent me his solution, which I'm going to share with you. And I'm also going to share with you my take on this problem. But before we do this, you can pause this video if you want to and try this problem out for yourself and then come back and check the solution. Alright, so let's solve this problem together. So first, I'm going to show you the Amir's method, which I call the symmetry of a circle. In this method, we're first going to label the center of our circle on the left, and we're going to pull a vertical line through this center. This line will be perpendicular to the length of our rectangle. Now we're going to use one really interesting circular theorem, which states that the perpendicular to a chord drawn from the center of the circle bisects the chord. In our case, you can see that we have the chord on the top and the chord on the bottom. So, since this line in the middle bisects this chord, this implies that the left part and the right part of our circle are identical, or that this midline must be the line of symmetry, which also bisects our two chords. Now, with this knowledge, let's pull a vertical line from the upper left intersection of our chord down to the side of our rectangle, and let's pull another line vertically up from the down left intersection of our bigger chord until the upper side of our rectangle. In this way, we will form this really nice small green rectangle. Now notice this upper left segment with the length of 11 and this bottom left segment with the length of 8. Now, if we want to calculate the length of the base of this newly formed green rectangle, we can clearly see that this base is equal to the difference between our top and the bottom segment, so it must be equal 3. So now, since symmetry applies, we're just going to take our green rectangle and move it to the right part of the circle. Let's do the same thing for our circle on the right. Let's pull a vertical line through the center, and of course this line will again bisect our top and bottom chord. Again, let's pull a vertical line from the upper right intersection downward, and let's pull another vertical line from the down right intersection upward. In this way, we will form another rectangle, this time the blue one. Again, you can notice that since the top right segment equals to 4 and the bottom right segment equals to 6, this means that the length of the base of this blue rectangle must be equal to the difference between those two, so it must be equal to 2. Now let's clear our image a little bit, and since symmetry applies, let's slide our blue rectangle to the left. Now notice the newly formed rectangle in the middle. In order to see it more clearly, I'm going to clear our image once again. And as you can see, this rectangle has the top side of x plus 2 and the bottom side of 3 plus 12. Since this is the rectangle, those two sides are identical in length. So from this we will get that x plus 2 equals 15, which means that our wanted segment x must have the length of 13, and this is our solution. Alright, so now let me show you my take on this problem. I'm going to use a little bit of a different method, which is the rectangle rotation. So I'm going to start the same way as Amir. I'm going to label the center of a circle and use it to pull a vertical line, which of course is perpendicular to the side of our big rectangle. Now let's notice the newly formed chord on the top, and let's use the same rule as before, that the perpendicular to chord drawn from the center of the circle bisects the chord. This means that our chord on the top can be divided into two identical segments, which I will label as A. Of course, I will do exactly the same thing for the chord on the bottom. It is also bisected by our vertical line, so I will label those two segments of this chord as B. Now, let's take a look at the circle on the right, and of course, let's do the same thing. First, for the chord on the bottom, I will label its segments as C, and finally, if we take a look at the chord on the top, I will label those two segments as D. Now, notice one more thing, that those two vertical lines from the centers of our two circles are actually dividing our big rectangle into three smaller rectangles: green one, red one, and blue one. Now, let's clear our image a little bit. So, my idea is to rotate the middle rectangle, this red one, and I'm going to rotate it 180 degrees, as you can see on the sketch. In this way, we have something really interesting. We can say that the upper line of our big rectangle equals to the sum of the segments of 11, A, C, 12, B, D, and 4. And the bottom side will be equal to the sum of the segments with the length of 8, BD, X, AC, and 6. Of course, both of those sides represent the length of the rectangle, so those two sides are equal. And there we have our equation. Now we can cancel A on the left and the right side of the equation. We can do the same thing for B, and for C, and finally for D. And we're left with the following. Now we can just calculate this and get that the length of X must be equal to 13, and of course this is again our solution. So I really think that this problem is not so difficult, and I can't wait to see how you guys found the solution to this problem. Of course, write it down in the comment section as you always do. And if you enjoyed this video, please leave a like or subscribe to the channel if you already haven't. And if you know a person who likes this kind of problems, be free to share this video with them. And until next time, see you guys and take care.